This video is sponsored by Brilliant. Hey guys, this looks like a fun one. We're given 3 circles with a radius of 4, and it's asking what is the total shaded area. This is day 23 of the 2025 Advent calendar. For the month of December, we're going to try to solve 31 Katrina Ag puzzles in 31 days. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, let's put together a formula for the area. These 3 regions are congruent, so we can say area equals 3 of those regions. This is what we're trying to solve. Let's put a box around it. And then from here, we're told the 3 circles each have a radius of 4. Due to symmetry and the fact that this circle has a radius of 4, this would have to be the center of the circle. And this intersection point would have to be the center of this circle. Let me know if that logic isn't solid. I would love to see a counterexample where these are not the centers of these circles with radius 4. So going forward with this as the center, let's draw this radius and label it 4, and let's draw the radius of this circle and label it 4. Inside of here we have a nice equilateral triangle. And then from here let's highlight this region yellow and this region red. And let's copy these 2 circles down here. Let's split them apart and rotate this one like this. It'll be true that in 2 circles with the same radius, if you have congruent chords, they cut congruent arcs. So this arc for the red region will equal this arc for the yellow region. So this yellow region is the exact same dimensions and size as this red region. That means if I pull this region out, I can replace it here. And now we have a sector of a circle. The notes say that the area of a sector is equal to this angle divided by 360 times pi times the radius squared. This sector belongs to this circle that has a radius of 4. We can change the r into 4. And then for the d, we need the angle right here. Let's draw this radius that's also equal to 4, and we have an equilateral triangle here. This angle of the sector will be 60 degrees. So we can change the d into 60. 4 squared is equal to 16, and then we can rearrange things like this. 60 times 16 is equal to 960, and then we can simplify this fraction. We can divide top and bottom by 10 to get rid of the zeros, and then 96 and 36 are both divisible by 12, so this will become 8/3 pi. And that is the area of this sector. And the area of a sector is the same thing as the area of one of these regions. So we can say the area of one of these regions is equal to 8/3 pi. And now I think we're ready to find the area. In the place of this region, we can plug in 8/3 pi. The 3 on top and the 3 on bottom can cancel each other out. So we're left with 8 pi. Let's give it a label of square units and put a box around it. This is the answer to our question. In this given diagram, the total shaded area is equal to 8 pi square units. How exciting. And I just realized something. If the radius of these circles is 4, that means the area of a whole circle is 16 pi. I think it's interesting that these 3 regions together have the same area as half of one of the circles. So if it's exactly half, I feel like we should be able to put these all into one circle. Let's move this one inside of this circle like that. Now we have a gap here. Let's bring this one down here. And that does look like half of the circle. That's pretty cool. So in this given diagram, the shaded region is equal to exactly half the area of one of the circles. How exciting. And then I thought of one other thing. If we make this a square root of 6, each of these regions will have an area of exactly pi. That would have been a pretty cool problem. Asking what is the area of each of these regions when that's square root of 6? And the answer is pi. Or here's another fun variation. Given that each of these has an area of pi, what is this distance right here? You may have to include some information about these being the centers of the circle or something else. How exciting. With Brilliant, you'll begin to click with concepts you used to struggle with. Each lesson is carefully designed by experts to make them effective and keep them engaging. They have an award-winning team of teachers, researchers, and professionals. What I personally like about Brilliant is I control the pace. If I pick up a topic quickly, I get to answer some questions and move on. And if I ever get stuck or confused, hints and explanations are just a click away. I never break my flow. In the new year, if you're going to set a goal to take learning seriously, Brilliant has you covered. They have tons of courses in math, science, and general knowledge. Or they can help you develop your problem-solving skills. To try Brilliant for free for 30 days, visit brilliant.org/andymath or scan the QR code on the screen. Or you can click on the link in the description. You can also get 20% off a premium plan with unlimited daily access. How exciting.